Today we're working in Chapter 5, Lesson 2, page 355. We are working with absolute value. Our learning targets today are that we will be able to graph integers on a number line. We can recognize opposites of numbers, and we can evaluate absolute values of numbers. The distance between a number and 0 on the number line is called its absolute value. Each mark on the number line indicates 1 yard. Draw a tree 3 yards west of the house. So the house is here, and each interval is a yard. So starting here, we would go 1, 2, 3 yards to the west of the house, and we would draw a tree. Draw a mailbox 3 yards east of the house. So again, the house is here, 3 yards east, 1, 2, 3, and we can draw a mailbox. Okay, 3 yards east of the house. The distance between the house and the tree is equal to the distance between the house and the mailbox. So they are the same distance away from the house. The tree and the mailbox are in opposite directions from the house. So one is west, one is east. Okay, the mailbox is east of the house and the tree is west of the house. How does the number line above help you to understand absolute value? The house is at 0 on the number line, if you can imagine this being at 0, okay? And the mailbox being 1, 2, 3 units to the right, so at +3, and the tree being at -1, -2, -3 units. Okay, so at -3. So the house is at 0 on the number line. The tree and the mailbox are the same distance from the house, but in different directions. So we use absolute value in math and in real life when we're more interested in the absolute distance or the absolute value that something has, and we're really not as interested in the direction. So if I asked you, how far away are we from Oakland Mall? And we know that Oakland Mall is at 14 Mile and John R, and we're at 12 Mile and John R, you would say we are 2 miles away from Oakland Mall. You wouldn't say we are -2 miles away from Oakland Mall. Okay, so distance is measured in absolute value. Yes, we are south of Oakland Mall, but we wouldn't say we're -2 miles away because we're not interested in the direction. We're just interested in the absolute value. In other words, how far would I drive to be able to get there? Okay. So example 5, errands. Jesse leaves home and walks 4 blocks west to the grocery store to buy milk, then returns home. So he leaves his home. So I'm going to make that 0. And then he walks 4 blocks west. So 1, 2, 3, 4 blocks west to the grocery store to buy milk, and then he returns home. So at 0, then goes to 4, and then goes back to 0. Compare the distance and the direction of Jesse's house to the post office from the grocery store. Oh, sorry. He then walks, let me read that again. Jesse leaves home and walks 4 blocks west to the grocery store to buy some milk and then returns home. So this is the grocery store. I'm just going to put GC for grocery store. He then walks another 4 blocks east to the post office. So 4 blocks east. So we'll make that -4 for west. Okay. So walks 4 blocks east to the post office. So PO for post office. Compare the distance and the directions of Jesse's house and the post office from the grocery store. So here's the grocery store, okay, 4 blocks west. They're both 4 blocks from the store, but in opposite directions. So compare the distance and direction of Jesse's house from the post office and the grocery store. So they're both 4 blocks away, but in opposite directions. Okay, so he can walk there the same distance, but opposite directions. So they are both the same distance from his house. But are in opposite directions. And turn the page to 356. So now we'll talk about opposites. Positive numbers such as 2 are graphed on the right or above 0 on a number line. Negative numbers such as -2 are graphed to the left or below 0 on a number line. So number lines can be horizontal, so going sideways, or they can be vertical, going up and down. So when number lines are sideways, negatives are to the left of 0, positives are to the right of 0. When number lines are vertical, so you can think of a thermometer, okay, positives go up and down, and the negatives go down. Okay, so we can have a vertical number line as well. Opposites are numbers that are the same distance from 0, but are in opposite directions of 0. So since 0 is not negative or positive, 0 is its own opposite. The opposite of a number is the same number itself. Okay, I'll say that again. The opposite of a number is the number itself. So for example, the opposite of 3 is 3. Oh, so that double negative concept. So -2 is 2 units to the left of 0. +2 is 2 units to the right of 0. Such as how we orient the number line. Let's look at example 1. Find the opposite of -5. So -5 is, if you drew a number line, -5 is 5 units to the left of 0. So +5 would be 5 units to the right of 0. They're in the opposite direction. So 5 is the opposite of -5. Okay. Another strategy that you can use is just looking at the symbols. The integer -5 uses the negative symbol. So the opposite of a negative symbol is a positive symbol, and therefore the opposite of -5 would be +5, or simply 5. So if we write just the number 5 and we don't write a negative in front of it, it is understood to be positive. Okay, so we don't need to write that positive sign in front of the 5. If there isn't a negative, it's assumed to be positive. Okay, moving on to number 2, find the opposite of 4. So if we start at 4, the opposite of 4 is -4, and the opposite of that is +4. So the opposite of the opposite is the number itself. And that'll become useful when we start adding and subtracting with positives and negatives. Okay, so that seems kind of nonsense, like why are we learning? Of course, the opposite of the opposite is whatever you started with. But when we start doing operations with integers, that will be helpful. Example A, what is the opposite of 3? The opposite of 3 is -3. And then example B, what is the opposite of -2? So if we take the opposite of -2, that's +2. And the opposite of -2 is, the opposite of that +2 is -2. So the opposite of the opposite is the number itself. Now we're at the top of page 357. We're looking at absolute value. The absolute value of a number is the distance between the number and 0 on the number line. So here is our number line. Okay, we have 0 in the middle, and 4 units left puts us at -4. 4 units right puts us at +4. These two numbers have the same absolute value because they are the same distance from 0. So the absolute value sign is written as these two vertical parallel bars surrounding the number. They are taller than, they start higher and finish lower than a number 1. So they're a little bit taller. So the absolute value bars, and that is an operation in math, just like adding is an operation, just like subtracting is an operation, just like multiplying is an operation. So when we take the absolute value, we're answering the question, how far away is the number from 0? So the absolute value of 4 is 4. And the absolute value of -4 is also 4. And this should make sense to you because they are both 4 units away from 0. That's how far away they are. So the integers -4 and 4 are each 4 units from 0, even though they are on opposite sides of 0. So this is red, the absolute value of -4. So when we see this absolute value bars around a number, we read it as the absolute value of, and then whatever the number is that's inside the absolute value bars. Number 3, evaluate the absolute value of -7. So when we are asked to find the absolute value of -7, that is simply asking us how far away from 0 is the number -7. So the distance it is away from 0, and that's 7 units away from 0. So if you can envision a number line or look at the number line that's printed for you, here is the number -7. It is 7 units to the left of 0. But again, the absolute value is not interested in the direction, it's just asking you how far away it is. Okay. Now we can also do operations that involve absolute value. So number 4, we have the absolute value of 5 plus the absolute value of -6. So we treat these in the order of operations in PEMDAS. Okay, remember the P stands for parentheses, the E stands for exponents, M and D, multiply and divide, that's done as one step from left to right. A and S, add and subtract, that's done as one step from left to right. Now you'll notice there isn't a special category for the absolute value bars. It actually fits in with the parentheses. So we'll start learning about GEMS or GEMDAS, and the G stands for grouping symbols. Okay, in these absolute value bars, when we are solving equations, when we are evaluating expressions, we will treat them as if in the same place that we treat parentheses. So they need to be done first. So just like we are used to doing operations inside of parentheses first, we also need to do operations inside of the absolute value bars first. So in the order of operations, we need to do operations inside parentheses, absolute value bars, square roots, which you'll learn about in 7th and 8th grade. Those items are all treated as grouping symbols. So I'm just going to briefly, and I'll still call this PEMDAS because we're really accustomed to that, but GEMDAS, or in the high school, some of the teachers will call it GEMS. We just look at the M and the as multiply and divide, and the A as add, or the S for the subtraction and addition. Okay, so now that we've established where that would happen in our order of operations, we'll go ahead and do that first because we know it does need to be taken care of first. The absolute value of 5 is 5. Bring down the plus sign because we're not doing that yet. We're doing the G or the P for PEMDAS. The absolute value of -6 is 6. And then the next step we do is we didn't have any multiplication or division. We didn't have any exponents. Okay, no exponents, no multiplication, division. So we move on to addition. 5 plus 6 is 11. So the absolute value of 5 plus the absolute value of -6 equals 11. Let's do example 5 together. Evaluate the absolute value of -7 minus the absolute value of 3. Okay, so first, again, with that order of operations, GEMDAS, okay, or PEMDAS. We want to do those grouping symbols first, okay? Absolute value of -7 is 7, and then just bring down the minus sign. The absolute value of 3 is 3, and 7 minus 3 is 4. Example C. What is the absolute value of 14? So that's just asking us how far away is 14 from 0 on the number line. It is 14 units away. The letter D. Absolute value of -9 is 9. And again, we're doing these first because of GEMDAS or PEMDAS. Okay, and that grouping symbol needs to be done first. Okay, the grouping symbols need to be done first. So we bring down the plus sign. The absolute value of 3. Well, how far away is 3 from 0? It's 3 units away. And then the next thing we do is adding, okay, because that's the only other operation we have. 9 plus 3 is 12. Example E, the absolute value of 8 minus the absolute value of -2. So first of all, remember our order of operations. Okay, we need to do the grouping symbols first. So the absolute value of -8, well, how far away is -8 from 0? It's 8 units away. Bring down the minus. And then the absolute value of -2 is 2. So we evaluate that and bring it down. Now we're done with our grouping symbols. We're done with our absolute value bars. We don't have any exponents. We don't have any multiplication or division. The next thing we have is subtraction. So we'll do that next. 8 minus 2 is 6. Okay, turn the page to 358. A seagull is flying 25 feet above. Okay, at the top of page 358, a seagull is flying 25 feet above sea level. Nevaeh is diving 15 feet below sea level. What is the distance between Nevaeh and the seagull? So if you can think of a vertical number line with 0 being at sea level and the seagull being 25 feet above, 5, 10, 15, 20, 25, and Nevaeh being 15 feet below, 5, 10, 15. So that's our -15. We know that we're 20 there. So this is sea level, and the distance from the seagull, 25 to 0 is 25 units. And then down to Nevaeh is an additional 15 units. So 25 plus 15 is 40. So the total distance is this 25 plus 15. So we're adding those absolute values. So that is 40 feet. Yeah, 40 feet is the distance between the seagull and Nevaeh. So we can also do that as an addition problem, which is what we kind of did here with the visual aid. So we don't have to necessarily write out the number line. We can just add those, the absolute value of 25 plus the absolute value of -15. So that would give us 25 plus 15, which would give us 40. So the distance between the seagull and Nevaeh is 40 feet. So you're just adding those two absolute values together. And that was chapter 5, lesson 2 on absolute value.